Hey there, Patriots. Let's go ahead and get started on Unit 5. Good news, only 2 more units to get through this semester. We've only got 6 units in Semester 1. So we're kind of winding down, kind of crazy to believe we've already finished up 4 units all the way through. So let's go ahead and jump into this. We have got an entire unit on just quadratics. Now this is going to be a pretty quick unit. There's going to be 3 lessons and a review, then a test. And we're going to start off with standard form. Now, standard form on a quadratic is just y equals ax squared plus bx plus c. Now, you remember these a, b, and c values because that's what we used back when we were doing the quadratic formula. Now, I want to go ahead and let you guys know that there is another form that we'll be using later on. And we're going to cover that, I believe, either next class or the one after that. And that is y equals a times x minus h squared plus k, which is very similar to what we did when we did transformations of functions. But that one will have different particular uses. But today we're doing things from standard form. So the first thing I want to go over before we get to this is let's remember what our parent function did. And I'm going to graph them on this particular graph. Actually, no, I'm going to come over here on the side. Okay, our parent function had this basic XY table. So we had -2, -1, 0, 1, and 2. Then -2 squared is +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So the basic graph, we had 0, 0, we had 1, 1, -1, 1, 2, 4, -2, 4. And so our parent equation, our parent function looked like this. These particular values, the one over here on the y column, are going to come in very important when we start graphing these here in a minute. So let's go and jump in here. Let's go ahead and just label these. We've got a equals 3, b equals -12, and c equals 11. Now I'm not going to be labeling these every single time. I just wanted to make sure that we remembered how to do those. Okay, the first thing we want to look at is what general shape is our parabola going to have? Now, when I say general shape, I mean, is it going to be opening up or is it going to be opening down? And in particular, you are looking at your a value. If the a value is positive, like this one is, then our general shape is it will be opening up. If a was negative, it would be opening down. Now, the axis of symmetry, what that is if I look at my parent function, you can see that all these points are actually symmetric about the y-axis. So I've got this line, I'm going to draw in red, that goes straight down the middle and everything is reflected over it, which means that if I went 1 unit that direction, I'd go 1 unit to the left. If I went 2 units to the left, I'd go 2 units to the right. The entire thing is completely symmetric. So that axis of symmetry always goes through the vertex. Now, that's important because we need to be able to locate the vertex in order to graph the line. To graph the parabola. So the first thing we're going to do is find the axis of symmetry, and then from there, use the axis of symmetry to find the vertex. And you'll see what that looks like in just a minute. Now, the axis of symmetry is always located at x equals -b divided by 2a. That's one of the formulas you're going to need quite a bit in this unit. So we're just going to plug it in. X equals, for b, we're going to have -12. And then for a, we've got a 3. So when we simplify that down, we've got +12 over 6, which is at 2. Now, what that means is if I go over to x equals 2, which is a vertical line, I'm going to have a vertical line right here that is my axis of symmetry. Now, to find the vertex, what I'm going to do is take the original equation, y equals 3. Now I'm going to put a set of parentheses here for all of my x's. And then I'm going to take this and substitute it into the equation. Substitute the axis of symmetry in. The reason I'm doing that is because I know that the axis of symmetry, the vertex is going to have the exact same x coordinate as the axis of symmetry because it lies on the axis of symmetry. So I'm going to plug in this 2 into both of those. And now we're just going to simplify. 2 squared is 4 times 3 is 12, minus 12 times 2 is 24, plus 11. Then when I simplify that down, that gives me y equals negative 1. Now, what that means is that my vertex is located at 2, negative 1. So if I go over to 2, negative 1, there is my vertex. Now, this whole idea right here of use A to get the right-hand man. When I talk about the right-hand man, I mean this y column, okay? What we're going to do is we're going to take the A value, which in this case, my A value is 3, and I'm going to multiply all of these times 3. So 4 times 3 is 12. 1 times 3 is 3. 0, 3, and 12. Now, what that means is, remember, these are all going to be relative coordinates off of the vertex. So we're going to basically go, excuse me, from the vertex, negative 2 and up 12. So left 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we're going to go negative 1, 3, negative 1, 1, 2, 3. Then 0, 0 is always going to be there. 1, 3, and then 2, 12. Again, you don't have to draw this, but notice we were talking about the symmetry. We got the symmetry going there and there. Okay, then we're just going to draw our line. Well, I say line, or curve. There's my parabola. Now, domain and range. Keep in mind that domain every single time is going to be negative infinity to infinity on every single parabola. You can't change that. Well, every single vertical parabola. There is a way of making a horizontal one, but we're not getting into that just yet. Now my range, we're going to look at our bottom value, which is going to be here at negative 1 to infinity. Okay, now for my y-intercept, the y-intercept is going to happen where x equals 0. So watch what happens here. Y equals 3 times 0 squared minus 12 times 0 plus 11. Well, this is going to go away. This is going to go away. It's just going to happen at y equals 11. So the y-intercept happens at y equals c, whatever your c value is. Okay, so my y-intercept is at 11, and yep, I had the point 11 right there. So there we go. All right, the rest of these should go a little bit faster than that one. Okay, general shape. I've got a negative 4, so this one is going to open down. Axis of symmetry is at x equals negative b over 2a. So that's going to happen at x equals negative b, so my b value is 8, so negative 8 over 2 times a is negative 4, which means that simplifies down to negative 8 over negative 8 is positive 1. Now let's find our vertex. That's going to happen at y equals negative 4 times 1 squared plus 8 times 1 plus 2. 1 squared is 1 times negative 4 is negative 4 plus 8 plus 2. So y is going to happen at negative 4 plus 8 is 4 plus 2 is 6. So axis of symmetry at x equals 1. Vertex at the point 1, 6. Okay, we're going to use A to get our right-hand man. And then I'm going to use a simplified version of that table. We had X, Y. I'm just going to do 0, 1, 2. And you know what, 3, just to see if it helps us. Now originally, remember that was going to be on the parent 0, 1, 4, and 9. We're going to multiply all of those times, in this case, -4. And so our coordinates are 0, -4, -16, and -36. All right, so we're going to go to 0, 0, 1, -1, 2, 3, 4. And then 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is about right there. Now, because this red line is an axis of symmetry, I can then just reflect this over to there and about there. Ooh, sorry, my tablet moved on me as I was drawing it. Okay, so sure enough, it opened up down. Now let's do our domain and range. Again, domain will always be the same, from -infinity to infinity. Range, now I'm going to write this below because it's kind of getting in the way of all the grid points. So we're going to have -infinity all the way up to 6. Okay, because 6 is our maximum value here. Now, y-intercept, again, that happens just at y equals c, so that's at y equals 2. Sure enough, crossed at 2. That's exactly what we were expecting. Okay, let's go through number 3. Now, one of the nice parts about this for that part 4 about using the right-hand man, we can go ahead and plot the y-intercept and then use that to reflect as a good point of figuring out exactly where this thing is going to go. So I'll show you what that looks like when we get to number 4 down there. Okay, general shape, I got a -1, so this one's going to open down. Axis of symmetry is going to be at x equals -b over 2a. So that's x equals negative times -2 over 2 times -1, which looks like I've got +2 over -2, which is -1. That means my axis of symmetry happens there. All right, let's go ahead and jump in and find that vertex. The vertex is going to happen at y equals, let's not do that in red, y equals -1 squared minus 2 times -1 minus 1. Now be careful with this because -1 squared is +1 times -1 is -1. Plus 2 minus 1, which happens at 0. So we're going to be over here at -1, 0. Okay, now I told you guys that you could do the use the y-intercept in order to do your a point to graph. So the y-intercept is going to happen at y equals -1, so y equals c. So right here at 0, -1, that is one of my points. And then I can reflect that over across the axis to get this one. So that can help you to get at least one point to graph. Now I'm going to go ahead and do the rest of this chart. 0, 1, 2, and 3. So that's 0, 1, 4, 9. Now in this case, I'm going to take all those and multiply them by -1 to get 0, -1, -4, and -9. So it looks like the only one I can really do here is 2, -4, 1, 2, 1, 2, 3, 4, and then reflect that over to there. There's my graph. Okay, domain and range. Once again, domain is all real numbers all the time. Range, we've got to start at negative infinity, and then our top value here is 0. All right, number 4. General shape. Again, I got a negative A value, which means it's going to open upside down. Axis of symmetry happens at negative b over 2a, and we're going to have to be careful here because we've got a fraction value for a. So it's going to happen at x equals negative b over 2a. X equals negative 4 over 2 times negative 1/2. Now that gives me a positive 4 over 2 times negative 1/2 is a positive 1. So that's just happening at 4. So I'm going to jump over here to 4. Change that to red. Now let's go ahead and find our vertex. Y equals negative 1/2 times 4 squared minus 4 times 4 minus 1. Well, 4 squared is 16 times a negative 1/2 is a negative 8. Negative 4 times 4 is negative 16, and then minus 1. And then negative 8 minus 16 is negative 24, minus 1 is negative 25. Well, you know what, I just realized I made this one too big. It's not going to fit on this graph, so we're not going to be able to graph it because it would be way down here somewhere. We'll go ahead and finish off the domain range and y-intercept though, just to be sure. So the y-intercept is going to happen at y equals the c value of negative 1. Okay, I'm going to have to erase and start over this entire problem. Okay, with number 4, general shape. I've got a negative 1/2 for my a value, so it's going to be upside down, pointed down. So our axis of symmetry, x equals negative b over 2a. Got to be careful on this because we got some fractions in there. So negative times negative 4 over 2 times negative 1/2. Well, that's going to give me positive 4 over 2 times 1/2 is 1, negative 1. So that's at negative 4. So let's jump over here to 1, 2, 3, 4. Now our vertex is going to go at y equals negative 1/2 times negative 4 squared minus 4 times 4 minus 1. Now negative 4 squared is 16 times negative 1/2 is negative 8. Negative 4 times 4 is negative 4 times negative 4 is positive 8 minus 1. Negative 8 plus 8. Oh, whoa. 4 times 4 is not 8. It is 16. So negative 8 plus 16 is 8. Minus 1 is 7. So my vertex is going to occur at negative 4, 7. Negative 4, 7. Okay, now let's do our chart. 0, 1, 2, and 3, and 0, 1, 4, 9. We're going to multiply all of those times the a value, negative 1/2. And that gives me 0, negative 1/2, negative 2, and negative 4.5. So we've got 1, 1/2, 2, negative 2, 3, negative 1, 2, 3, 4 and a half to reflect all of those over the axis of symmetry. And I'm going to go ahead and get my y-intercept. Y equals negative 1. So that's going to happen here. oh, not that positive 1, negative 1. And let's go ahead and reflect that over to there. And here's my graph. Domain is negative infinity to infinity. And my range, negative infinity to the top value, which is 7. Okay, so now find the minimum or maximum value for each function. Well, now if you look at all of these, the minimum or maximum value always happens at the vertex. So when we say minimum or maximum value, what we mean is the y-coordinate at the vertex. So that's really what we've been doing on part 3 of all these different problems. So first thing we need to do to find our minimum or maximum value is find the axis of symmetry, negative b over 2a. Now in this case, be careful because my b value is 0. So that's negative 0 over 2 times 9, which is 0. Now when the axis of symmetry is 0, then that really just means that the vertex is going to be the y-intercept. Because when I go to plug that in, I'm going to get 9 times 0 squared plus 7, which is just 7. Now, we need to actually also say whether or not it is a minimum or a maximum, and we can tell that based on the a value, because this positive 9 means it's going to be opening up. So this y equals 7 is going to be a minimum value. Now, on this one over here, I can see that a value of negative 1/4 is going to be opening down, so this is going to be a maximum value. Let's go ahead and find our axis of symmetry. X equals negative b, which is negative 7, over 2a, which is negative 1/4. So that's positive 7 over 2 times negative 1/4 is negative 1/2. Now, if you remember our fraction rules, whenever you divide two fractions, I'm going to go ahead and make this top a 7 over 1. When you divide two fractions, it's the same as multiplying by the reciprocal. So that's going to equal 7 over 1 times the reciprocal of negative 1/2 is negative 2 over 1, which is at 14. Oh, sorry, negative 14. So now, let's go ahead and do the y value there. Y is equal to negative 1 over 4 times 14 squared minus 7 times 14 plus 2. And now that just got too rich for my blood. Just to make sure, let's make sure we did that right. 2 times negative 7 divided by 2 times negative 1/4. I'm hitting the wrong buttons. Negative 14, that's good. Now negative 1/4 times 14 squared minus 7 times 14 plus 2 is negative 145. So I've got a maximum value at a negative 145, which, I mean, when you think about that, that probably is gonna start, let's just draw this, way down here at negative 145. Then this thing is going to come up and do that, and that's the maximum value there. So that's really far down there. Okay, now let's write the equations and graph them in standard form. So what we're going to do is be using either our TI-83 calculator or the Desmos regression calculator in order to find our A, B, and C values. So what we're going to do is find the location of at least 3 points on the graph. And then if you're doing it on Desmos, it's going to look one way, and I'll actually flip over and do that here in just a second. I'm going to do this all on the calculator first, and then I'll switch over to Desmos for those of you who don't have the calculator. Remember that if you have a Chromebook issued by GISD, even if it is the not so nice non-touchscreen ones, they've all got the TI-84 app on them. So you can use this calculator exactly as I'm about to do it. So here's what we're going to do. Let's find the coordinates of 3 of our points. Now, there are 3 points here. So this first one, the vertex, is at 1, 1, 2, 3, negative 3. Then we're also at negative 1, 5, negative 7. And then this point over here is at 1, 2, 3, 3, negative 7. Okay. So let's go up to type the 3 points into stat edit. Stat edit. Now, if you've got stuff in here like I do, what you want to do is you want to press the up arrow and highlight L2. Now, do not hit the delete button. You want to hit clear, enter. If you press delete, you're going to screw yourself up, okay? Actually, I'm going to go ahead and show you what happens there, okay? I'm going to press delete, which I told you shouldn't do. Whenever I do that, notice L1, L4, L3, L2. I'm going to press left one more time. L1 has disappeared, okay? If that happens, what you want to do is you want to go to Stat and then go to option 5, which is Setup Editor, and press Enter. Now go back to Stat Edit, and it'll be there, and there's still data in it. So it didn't do you any good. Go up and hit Clear, Enter. Okay. Now, we're going to put the X values in L1, Y values in L2. So we've got 1, negative 1, and 3. L2, we've got negative 3, negative 7, negative 7. Now, we're going to go to Stat. We're on this step here. Arrow right over to Calc. That's where this Stat Calc comes in. Then we're going to go down to Quadratics and press Enter on it. Now, it's going to ask you for all this L1, L2, just arrow all the way down and hit Calculate. When it does that, it's going to give you your A, B, and C value. So I know my equation is y equals negative x squared plus 2x minus 4. Okay, let's do that exact same thing with the next one. Our 3 points here, looks like I've got negative 1, negative 2. I've got the point 2, negative 2. And I've got the point 1, 2, 3, 2. So, same steps as before. Go to Stat. Go to Edit. Up and clear, Enter. Clear your lists. Don't delete your lists. X values go in L1, 2, 3. Negative 2. Make sure you're pressing Enter after each one of these. Then we're going to Stat, over to Calc, down to Quadratics, and then down to Calculate. So my equation is y equals x squared minus x minus 4. All right, now let's switch over and show you how to do this in Desmos. I'm only going to do the first one because it's the exact same process for the second one. Now there's that link there that's big and complicated. Honestly, you can just go to Google and type in Desmos quadratic regression, and it'll be this first option right here. Now remember that this is got a whole bunch of stuff in it, and we're going to have to delete all those out. I'm just pressing the delete button on all these. This one you can press delete, you don't have to press clear. Okay, now same idea as before. We're going to take all of our x values and put them into x1. So we've got 1, negative 1, 3. And then we've got negative 3, negative 7, negative 7. And we can see we got our A, B, and C value. A is negative 1, B is 2, C is negative 4. Oops. And negative 1 to negative 4. Same process, quite a bit easier on Desmos. Just want to show you how to do it on the calculator too, because that's what you're able to use on things like the SAT ACT, any other standardized test, you're not going to have access to things like Desmos. So that's all that we have got for you guys today. Good luck on that homework assignment.